Okay, example 10, this weird looking function. When I did this one on Desmos, and now I'm going to have you guys finish this on Desmos in a little bit, I changed all the y's to x's just to, I just think it works better to have it in terms of x. But for right now, when we solve this, we're going to have this in terms of y. So this function, I really don't want to deal with this fraction. Okay, so I'm going to rewrite this function, but I'm going to divide everything by y squared. So y to the third divided by y squared is just y, minus 2y squared divided by y squared is just 2, minus y divided by y squared is 1 over y. So that is going to be a lot easier to take the antiderivative of. So the antiderivative, if we want y, you know that this has to be y squared, but then if you would bring the 2 in front, we don't want it to be 2y, we just want it to be y. So we would need to have a 1/2 right here. Does that make sense? So if you take the derivative of this, and it leads you to y. Okay? If you just have a constant, that's easy. It just becomes 2y. When you take the derivative of negative 2y, you get negative 2. Oh, and here's the one that stumps me every time. That is the natural log. That's the only way you can do that, the natural log of y. So now we're ready to go. We're just going to take f of 3 and subtract f of 1. Now, when you have a more complicated one like this, I think it's a good idea to show your work in 2 separate brackets like this. Okay, so if we plug 3 in, we're going to take a half of 3 squared. So half of 9, I know, is 4.5. And then negative 2 times 3 is minus 6. And then the minus natural log of 3, whatever that is. Okay, then we're going to subtract what we get when we plug a 1 in for all the y's. So half of y squared would be 0.5 minus 2 times 1 is 2 minus the natural log of 1. And then when you just type this in your calculator, you get roughly negative so let's put the squiggly equal line, negative 2.599, and then this is going to become minus a negative 1.5, so it's going to turn into plus, and your final answer being negative 1.099. Okay, I've already typed this into Desmos for you, and so first let's just check our answer, and we can see negative 1.099 is roughly what we have. Okay, and then here I graphed the function. So this is a weird looking function, so you just want to show your shading from 1 to 3. So hopefully it makes sense that you have more shading below the x-axis than above the x-axis, and that's why it led to that. So I would like you guys to, okay, so what we can do before we start writing like our f of x and our capital F of x is rewrite the integration. You can, this 4 is just a constant, so you could put that out front of the integration symbol, leaving you with this. And like what we saw in our book, notice I don't have this integral anymore. Like I'm applying this integral right here inside the brackets. So this is maybe some new notation if you have like a more complicated problem. It means this 4 is hanging out by itself, but we want to evaluate this, the inverse sign from 1/2 to 1 over radical 2. So now we're going to apply this fundamental theorem of calculus part 2, like what we've been doing up here, where we're going to plug in f of, you know, this number minus the capital F of this number. But then we're going to multiply our final answer by 4. So if we think of inverse sine, remember sine is opposite over hypotenuse. If we want to go, let's start with this one. 1 over radical 2. Do you guys remember a 45 triangle is 1 radical 2? And a 45-degree angle is the same as pi over 4. So the sine of pi over 4 is 1 over radical 2. This is saying, hey, what sine of what leads you to 1 over radical 2? And that's pi over 4. So we're going to have pi over 4. That's like our capital F of this minus our capital F of this. So now we have 1/2. So think of what kind of triangle has a 1 here and a 2 here. It's a 1, 2, radical 3 triangle, which is 30-degree triangle. And that in radians is pi over 6. So we have pi over 6. And when you subtract pi over 4 minus pi over 6, it's pi over 12. So our final answer is 4 times pi over 12, which is roughly, well, let's write that as exactly pi over 3. That's the exact answer. But if you type it on Desmos, you're going to get the rounded answer. Okay, and that is correct if you check that on Desmos. All right, and example 12, this one's a little bit easier and less complicated. So here he asks you to sketch the graph, but we've been doing that the whole time. I know I skipped that on 11. I'm just gonna write skip graph just to save us a little bit of time. I know this is time consuming. So I would like you guys to try example 12 by doing the graph and doing it by the fundamental theorem of calculus. This one should be pretty simple. Maybe email me this or get it checked before you start on your quiz. So again, to get started on this one, I would just write f of x equals 2x. So all you have to do is find the antiderivative, okay? Then the antiderivative at 3 minus the antiderivative at negative 3. So you need to fill in this, and you need to sketch this graph. Okay.